Alright, today we're going to be talking about the point-slope form equation, and it is written as follows. Y minus y1 equals m parentheses x minus x1. So what we're going to talk about for just a moment is what each of those letters in this equation mean. So I'm going to start with the most obvious. The m is going to be our slope. Then we have x, we have y, we have x1, and we have y1. So these two are partners that make up one coordinate pair on a graphed line. So example, x comma y. That is one point somewhere on the line. For example, this could be x, y. Okay? And then we have x1 and y1, which are also partners that make up one coordinate pair on the graphed line. So separate partners. So both of these are partners except I'll maybe use a different color. So this right here, this purple one, is going to be x1 comma y1. So both of these represent two separate coordinate pairs that appear on our graphed line. So we're going to show about what examples we might need this type of formula or this type of equation. So my question is, what would have to be given in order to use the point-slope form equation? So I'll give you a minute to think. So there are two scenarios, and maybe you thought of these, but in one scenario, you would have to be given one slope and one point, meaning one xy pair. Or the other thing that you could still use this point-slope form equation would be given two coordinate pairs on the line. So those are the two scenarios that we're going to look at first. The first we're going to look at, given one slope and one point, how could we put this into an equation? So our first example is when given m equals 1/2 and we have our xy pair here, how could we put this into our original point-slope form equation? Y minus y1 equals m parentheses x minus x1. So obviously we can take our slope and put it here. So I have equals 1/2. And then in our equation, when we see this, just like in y equals mx plus b, this guy and this guy are going to stay they're going to stay y and x. Just like in y equals mx plus b, the m and the b change, but the y and the x are just chilling. Okay? So that means our y1 is going to be here, and our x1 is going to be that -2. So now let's fill in the blank. So if I say y minus 4 equals 1/2 times x minus, we have a -2. So the thing about this one is that we can simplify that a little bit further. So y minus 4 equals 1/2 parentheses x, and then when we subtract a negative, we're going to actually be adding. So this would be the equation when if they asked you to write an equation when you were given one slope and 1 point on the line. You would be able to use point-slope form to graph your line. Okay, the next thing we're going to look at, the next scenario is given 2 points on a line. So both of these coordinate pairs appear on our graphed line, and they said, write an equation in point-slope form using this equation. So let's write our equation again. Y minus y1 equals m parentheses x minus x1. So in order to do this, we need an x1 and a y1, and we need a slope. So the x1 and y1 is easy. We can just use this. We could say this is x1, this is y1. I could also use this one here, but I'm just going to use that one. We also are going to need a slope. So in order to find a slope, there are multiple ways we could go about doing this, but the easiest way is to use our point-slope form, the slope of a line formula. Slope of a line, which is y2 minus y1 over x2 minus x1. So since we've already assigned this one as x1 and y1, let's go ahead and assign this as x2 and y2, and then substitute our numbers in. So y2, we have y2 right here is, I forgot 10. So let's go ahead and try that again. So we have y2, which is 10, minus y1, which is 4. Then we have x2, that is 4, minus x1, which is 2. So then we would simplify. 10 minus 4 is 6, and 4 minus 2 is not 3. 4 minus 2 is 2. And when we simplify that, we get a slope of 6 divided by 2, which is 3. So now we can take that information and now write our point-slope form equation. So since we now have our slope. So we have y minus our y1, which is 4, equals our slope 3, parentheses x, minus our x1, which is 2. And that would be our equation in point-slope form. All right, now I'm going to show you 3 different IXLs and one example from each that will hopefully help you finish the assignment on Google Classroom. So yours may be in a different order depending on your class, but once you open the IXL, the first one that you should be looking at is S.23, and it should look like this example. They could be in a different order. I don't remember how I posted them in your specific Google Classroom. But this one, we have a line that has a slope of 8 and passes through the point 10, negative 4. What is the equation in point-slope form? So when you see this one on IXL, you're going to take what's given. So we're given a slope of 8, and we're given a point 10, negative 4, which is our x1 and y1. And we're going to place them into the form of the equation. So y1 is negative 4, so we would put a negative 4 there. x1 is 10, so I would put a 10 there. And then our slope is 8, and I would put that there, and then you would push submit, and it would say, awesome job. So on this one, we're just taking what's given and then substituting them into the equation. And then recognizing that if the whole box is there, if the subtraction sign is in there, we're going to just write a negative 4. Whereas if you're having to simplify, you could also write y plus 4 equals 8, parentheses, x minus 10. But that's only if you're given like a whole box to type in. But if they have the individual boxes, like these, the individual boxes, you'll make sure to include the signs accordingly. So that's IXL S.23. The next IXL is S.24. So again, it's in the top corner of your page at S.24. And you'll have a graph, and these will be the instructions. It'll say, what is the equation of the line in point slope form? So again, we have these individual boxes that we're going to need to fill out. And let's do that. So in order to fill out this box, we're going to need a y1. In order to fill out this box, we're going to need an x1. To do that, we're going to use, so it says right here in the directions, use the red point in your equation. So we're using this red point that's given. So let's look at this here, and we're going to write a coordinate pair for the red point. So the coordinate pair here is going to be negative 600, negative 700. So negative 600, negative 700. So this is x1, this is y1. And so now in my boxes down here, my x1 is going to be negative 600. And my y1 is going to be negative 700. And then we're going to have to find our slope. But since they gave us a graph, we can find two pretty points and do rise over run. So for the slope, we're going to find two pretty points and rise over run and simplify. So with this one here, so we have one pretty point, the red one, and then I'm going to try and find my next pretty point. So if I go along my line, I'm looking for my next pretty point, and I see it right here. So this is my next pretty point on my line. So what I'm going to do is now find my rise over run. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So I went up 8 spaces, but if I notice my intervals, my interval is counting by 100. So this is actually an 800. And then I'm going to go 1 space to the left, so it's a -1. But if we notice the interval on the x-axis is also going by 100s. So we have a rise of 800 and a run of -100. So when we simplify that, we're going to have a -8. So our m is going to go here. It's going to be 8. And then you would push submit, and they'd say, awesome job. And the last one is S.22. So you should get one that looks like this. Again, S.22. I think in 4th period, 4th, 6th, and 7th, the correct order is this video, but in 2nd and 3rd, they're in different orders. So make sure you're looking at the right IXL before you follow this video. So this last one, they're going to give you a function. In this case, they're giving us y plus 4 equals 1/4 x plus 4. So we know in order to graph our line, we need a slope and we need at least 1 point. We need an xy. So from our formula, we know that the slope is right here. We have 1/4. But there's no way we can take this slope and put it on our graph without a starting point. We can't just start counting 1/4 wherever we want. So that's why we need one xy pair. So we know that this plus 4, these 4s are both representative of a part of a coordinate pair. So I have a x that is 4 and a y that is also 4 if I'm looking right at the equation. But wait. Okay, our original equation is y2, or y minus y1 equals m parentheses x minus x1. So if that is our original equation, in order for this 4 to have become positive, what is true about the original x1 that we just wrote over here? So I hope that you recognize that this x1 has to be negative in order, oh, sorry, I'm looking at, they're both positive. But, so I guess I should be looking at this. This x, for this x1 to be positive in this formula, or in this equation, it has to have started as a negative. And the same thing is true about my y, is that in order for it to be positive 4 in the last equation, it would have had to start as a negative 4. Let me just show you really quick so that it's clear before the video is over. So y minus y1, so if y1 is negative 4, equals 1/4, close parentheses, x minus 4. So when we, now, if we're to simplify, when we subtract a negative, we are adding. So y plus 4 equals, this is supposed to be 1/4. 1/4, and then x minus a negative is x plus 4. So that's where those came from. So now, what we need to do is take our coordinate pair and our slope and make a line. So I'm going to have to erase this to have room. So we have one coordinate pair that's at -4, -4, -4. So this is this point here. And then what we're going to do is use our slope to count from this point to our next point. So I'm going to rise 1 plus 1, and I'm going to run 4 plus 4. So that's my rise over run. So I could keep going, rise 1, run 4. And then from there, we'd have our line, and you would submit it, and you would say, awesome job. So there are the 3 IXLs, S.23, S.24, and S.22. And these all need to be at different SMART scores. If you're in 4, 6, and 7, you need to get a 50 SMART score. And if you're in 2 and 3, you need to get a 60 SMART score. All right, and I hope this helps.